Okay, so I'm going to give an update today on the Cryo device here. A number of things have happened. I think I may have recorded a video in which I was collecting the data to train a model to then be the simulator to then train a controller to control the heater and the plunging into the liquid or whatever. So in this setup, this is all just with ice. I'll do it next with the liquid nitrogen. So there's a big chunk of ice in here. This can lower down and raise, and so it could plunge it into that ice water, but will be liquid nitrogen. And then there's nichrome wire wrapped around this little well here, and that's where the specimens will go in. Okay, and then there's a whole setup to capture that data and whatnot. So here on the computer, this is data of okay, right. So what I did first was just recorded a ton of runs of just random controls and logged the temperature. So the temperature response to the controls, so the heat and the power. I then trained a model to predict temperature from the control input. And that's what this is. So here, the blue is the true values. So down below are these are the controls. So this is when heat was applied. This is when it was plunged in. The purple or whatever blue down there is when it was plunged. And then the actual lines here are the temperature curves. And the blue line is what was actually measured during the data collection. And then the orange line is the predicted. So starting from that point and then not seeing any of the other true values, but just seeing the control inputs. What does this train simulator, how can it perform? So that was really good. Got that to be, sufficiently accurate. There's a lot more bells and whistles I could add, but I needed to move on. We'll get to that. Okay, and then I went and trained a controller on that simulator, so to actually control the temperature to a desired temperature. So here we have the green is the target temperature in all these different runs, and then the blue is the simulated temperature, so what it actually is, and then the red and the blue down here again are the controls. So the blue here is when it's plunged. This is just power off. And then up here, the higher red is when like more power is being applied, but it's not plunged in. And so it's able to, kind of rapidly, so at around 1 to 2 degrees per second, both cooling and warming, get it down, which is pretty cool. And I'll show that in a second. But yeah, so those all look good. And then this is what I'll show in a second. This is it actually controlling the temperature. So here it's up at 60 degrees, and then I command it with the green line to go down to 30 degrees. And then, and that's when in this plot, this is sort of a purple is when the cool is on. So that means when it's plunged, so that it plunges till it gets down to that 30 degrees. And then I changed it and said, okay, now I'll go to 60 degrees again. And then it is to turn the power on and then kind of turn the power off and then kind of needs to keep it on. So again, with this, there's a lot that can be improved, but it's kind of, time to move on. So maybe others I could bring on and they'll have time to keep improving this. Okay, so let's look at it now, which is kind of cool. So we'll run this guy. Let me make sure the liquid level is good. Yes. Okay. So, all right, launching. Okay. So, right. So it started at about under 20 degrees Celsius, and then the first initial commanded position was 30 degrees Celsius. So it's roughly holding it certainly within my tolerance of 5 degrees. But it's holding it there, and now we can command it to go to I don't know, let's say 50 degrees. So we'll command it up to 50 degrees. The controller sees that target temperature, turns the power on. That's this power on, and then we're rapidly warming up. So in here, you can't see it, but yeah. So the power, I can kind of smell it because I think some Actually, I don't know why I can smell it. I think it might be some of the thermal adhesive that I'm using that I'm able to smell when the nichrome comes on. But yeah, so it does a great job. Comes up, holds it really well, and then gives these little pulses. And then if we go down to say 25 degrees, which I don't know, I never commanded it intentionally below 30 degrees, but we'll see. So now it turns off the power, plunge. You heard it, ring. So move down a little bit. That's because it's actually plunging that well down in the liquid. Yeah, and it's pretty cool. So it's plunged down in, and it's slowly getting there. Obviously, the temperature difference between the liquid and the commanded slows down the rate of change of that. That's Fourier's law of the heat transfer. Depends on the difference between those two temperatures. But yeah, so as it gets close, it should turn off. We should see it turn off turn off the cool, which means just kind of raise it up out of the water bath. Yeah, and then it's at 25 degrees, or excuse me, 20, what do we command it to? Yeah, 25 degrees Celsius. All right, so that's it. This was a massive project. It felt like a massive project past couple weeks, and but now I'm gonna go get out some more liquid nitrogen, and then I'll collect that data. But all the code is set up and the hardware. I can't wait to come back around to this because I want to improve all this setup. I have other ideas for a different device and whatnot, but I think I'll try to get through the full cryopreservation, or at least some experiments before I start improving on this stuff. Okay, that was it.